So last time we talked about radioactive decay and we only managed to talk about the alpha decay. Today we're going to proceed and we're going to be looking at the beta decay. So during beta decay, the number of neutrons decreases by 1, whereas the number of protons increases by 1. This is because during beta decay, a neutron splits into a proton and an electron, and the resulting electron is emitted as a beta particle. So when an atom emits a beta particle, it turns into an atom of the element which is one place later in the periodic table. So when an atom emits a beta particle, so you can say that when an atom emits a beta particle, it turns into an atom of an element which is one place later in the periodic table. In the periodic table. And during the beta decay, the mass does not change. The mass does not change during the beta decay. So the mass does not change, or the mass will remain the same. And the atomic number will increase by 1. So during a beta decay, the mass does not change, but the atomic number will increase by 1. So the mass does not change while the atomic number will increase by 1. That means that the atomic number of a daughter nucleid is going to have 1 more than that of a parent nucleid. And to write the general equation, we can say a nuclear equation. So for the nuclear equation, if we have this element X, so that's the symbol, and we have the mass number there, and the atomic number of a parent nucleid, and if this produces a daughter nucleid, and when it emits a beta particle, we know that the mass number will remain the same, so A is going to maintain there, while the atomic number will increase by 1. So we can say Z plus 1, and Y there represents the symbol of the daughter nucleid, so we can say plus electron there, which is the power 0, and negative 1. So if we write down this nuclear equation, we know that the element has emitted a beta particle. Let us look at an example. So the example reads, carbon 14 is a beta particle emitter. Using the periodic table, find the isotope in which it decays. So carbon 14 is a beta particle emitter. Using the periodic table, find the isotope into which it decays. And if we check on the periodic table, carbon, the atomic number of carbon is 6, and we know that carbon 14, that's one of its isotope. So we have carbon, which has the mass of 14 and the atomic number of 6. So if this emits a beta particle, we know that the daughter nuclide, the mass will remain the same, which is 14, but the atomic number, which is 6, will increase by 1. So we can say 6 plus 1, which is 7. So we're going to have 7 there, plus we have our symbol there of a beta particle. So if we check this element on the periodic table, we're going to find out that this is nitrogen. So we can write down another equation there. So this is nitrogen if you check that on the periodic table. So to answer our question, which says using the periodic table, find the isotope into which it decays. So it decays into nitrogen.